So today I will present you the most important model of neuroeconomics. This is a diffusion model of decision making. So we'll try to understand how neurons are programming our decisions. As you know, neuroeconomics is trying to understand how sensory information is transformed into decisions. So somehow information is collected by our sensory organs, and next we estimate alternatives and make a decision. So today we will see how neuronal populations are programming our decisions. According to the neuroeconomics view, our decisions are products of the activity of our neuronal populations. So somewhere in neurons, in neuronal activity, our decisions are programmed. How can we study this process? We can record the single neuron activity. As you know now, we can record single spikes, our firing rate of these neurons. We will see today how firing rate, how the number of spikes per second can actually indicate the process of decision making. As you see here on this graph, we can record a single spike, a single action potential. But during the experiment, we can record a number of spikes that is produced by the neuron. Here you see an example of the activity of a neuron during a task. Each line represents a trial. We see a cloud of spikes at certain time window. So at this moment, a neuron produces a lot of spikes, a lot of action potentials. This neuron is activated. It is a bit easier to create a histogram, as you see below this graph, and this histogram, this graph, represents the firing rate, the number of spikes per second. Here on this graph, we clearly see that this particular neuron is activated, produces a lot of spikes at certain time window. So today you will see few of these graphs like this, representing the firing rate during the decision-making process. So let's move into neuroeconomics. Please make a look to this image. What do you see on this screen? Perhaps some of you are confused, but this is a very famous picture that is presented in many handbooks on cognitive psychology. So I can actually change my question. Do you see here a house or a dog? Some of you perhaps will recognize the dog at the center of this image. Yeah, so somehow our brain is capable to process very complex, noisy information and reconstruct an image of an object, so of the dog. And this is an example of the perceptual decision. So perceptual decisions are those decisions where decision makers categorize ambiguous or noisy sensory information. Surprisingly, first neuroeconomic studies used perceptual decision tasks to investigate the decision-making process. And actually, they use quite strange stimuli. Please make a look to this image. Do you recognize this image? So perhaps it's not easy, but now I will add some motion to this image. And perhaps you clearly can recognize a moving person. So our brain is very sensitive to motion. We have specialized neurons that are particularly sensitive to motion information. And this very nice technique illustrates our particular specificity, our specialization of our brain on moving information. Actually, our brain can extract a lot of complex information from moving patterns. So, for example, here you see that quite complex patterns are clearly recognized as particular objects, as a particular information. So our brain is very sensitive to motion, and there are specialized neurons that are sensitive to motion. And interestingly, first neuroeconomic studies actually investigated the behavior of neurons that are sensitive to motion. Let's make a look now to this first neuroeconomics task. This is so-called perceptual discrimination task. So here, an animal, a monkey, has to switch gaze in certain direction. So this monkey has to switch gaze right or left. So it has to switch the gaze in the same direction as the majority of dots are moving on the screen. So if the majority of dots are moving right, animal has to switch gaze right. If the majority of dots are moving left, monkey has to switch gaze left. Of course, dots can move in various directions. So with this very simple task, we can create different levels of the difficulty of the task. So if all dots are moving right, this is a very simple perceptual decision because it's really clear that all dots are moving right. If only 50% of dots will move right, it's a relatively difficult task, but it is still possible to recognize this motion. But if all dots are moving in random directions, it is almost impossible to basically make correct decisions. Only by chance monkey can make it. So this is a very difficult perceptual decision task. So we can now study how does brain of the monkey makes a simple perceptual decision, whether dots are moving right or left. So here you see the actual stimuli used in the first neuroeconomic studies. So for example, this video represents the easy task. Here all dots are moving in the same direction. So it is really easy for the monkey to recognize the right motion and make the correct decision. In the next video you see a more difficult task. Here only 50% of dots are moving right. So it is relatively difficult to recognize this motion, but it is still possible. And here you see the most difficult version of the task. Dots are moving in random directions, so monkey can make the correct decision only by chance. So how does brain of the monkey makes the perceptual decision to switch gaze right or left depending on the perceived motion on the screen? Neuroeconomists suggested a very simple model. You can imagine that visual information is projected on our retina, and next, information is delivered to the visual cortex. Imagine that there are motion detectors in the brain, left motion detector and right motion detector. These neurons are sensitive to motion. Activity of these neurons is proportional to the amount of motion on the screen. And next, there are decision-making neurons, a network of neurons that simply compare the activity of the left motion detectors and right motion detectors. So if we'll use labels activity A and activity B, these decision-making neurons will decide that monkey see left motion if activity A is larger than activity B. And monkey would decide that monkey observe the right motion if activity B will be larger than activity A. So this network of neurons, decision-making network, simply compares the sensory evidences for alternatives A and B, for left and right side motion. So let's next make a look to the actual behavior of the neurons in the brain of the monkey.